Okay, here we're going to be adding or subtracting three polynomials, and they all have the same variable, so we're only worried about looking for like terms here. So let's take a look at what we have. We have our first polynomial, our second polynomial. We're going to add those two together, and then we have our third one here. Right, so if I'm adding polynomials, I really don't have to be too concerned. I can just simply remove my parentheses. However, if I'm subtracting, I need to make sure I have a -1 there in front of it. Okay, so that -1 is going to get distributed to every term inside those parentheses. So here, my first two, it's just an addition, so I'm going to write 3v squared minus 3v minus 9. And then I have a plus. And I simply take everything out of the parentheses, plus 2v squared plus 6v minus 8. And now this last part, since it's a subtraction, I have to distribute my -1. So I have a -1 times a negative v squared is going to give me a positive v squared. -1 times a 3v is going to be a negative 3v. And a -1 times a -7 is going to be plus 7. Okay, so now I'm going to start looking for like terms. It's just a little bit of a longer problem, but it's still the same basic rules. I'm going to look for, I have a 3v squared here, plus a 2v squared, plus a 1v squared, right? If I don't see a coefficient, I assume it's 1, so I have 3 plus 2 plus 1, and that gives me 6v squares, right? Then I'm going to go to my v's. I have a -3v, and then I have a plus 6v, and I have another minus 3v. So I have a minus 3 plus 6 gives me a positive 3, then a minus 3 gives me really 0 v's. And then the last part, I have my constant terms here, so I have a -9 minus 8 gives me a -17, plus a 7 gives me a -10. So this 0v just simply goes away, so my answer is going to be 6v squared minus 10. Okay, let's try another one. All right, again we have three polynomials. So I see this one plus the second one minus the third one. And remember, if it's a subtraction, I have to remember that I have a -1 in front of the polynomial. And before I remove the parentheses, I have to distribute that -1 to every term inside. So with the first two, it's simple addition. So I'm just going to take off the parentheses, and I have -2w squared minus 3w minus 8 plus, and then I have a -4w squared. And I just put that in parentheses to keep it, to know that it's by itself there, plus 6w minus 4. And then I'm going to distribute this -1 to everything inside the last polynomial. So I have a minus 4w squared. A negative times a negative gives me a positive 7w, and a -1 times a -6 gives me a positive 6. So here I am with kind of a long expression, but I'm going to simplify it. And I'm going to do that by looking for like terms. So I'm going to start off with my w squares. Now remember, when I'm adding, this is all the variable part, right? So I have w squared here and a w squared here. I don't change that at all. I don't add my exponents. I simply add the coefficients that are in front of it. So I have my w squared term, and I have a -2 minus a 4, that's going to give me a -6, minus another 4, so that's going to give me a -10w squared. So now let's take a look at the next one. I have a w. So here's -3w plus 6w gives me 3w, and then plus a 7w is going to give me a plus 10w. And then my last, or my constants, I have a -8 minus a 4, that's going to give me a -12, plus a 6. -12 plus 6 is going to give me a -6. So my answer is negative 10w squared plus 10w minus 6.